Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 59 from the Smith Organic Chemistry textbook. In this problem, it gives us two sharpless epoxidation reactions and asks us to draw the products. The first thing that we have to do for A is going to be to redraw this. So the book advocates an approach that I like where we draw. So a sharpless epoxidation is gonna always involve an allylic alcohol, and so we should draw these molecules such that the double bond is horizontal and the allylic alcohol is to the top right. And when we do that, it standardizes the drawings, and we can very easily determine where the oxygen for the epoxide is going to be in terms of its stereochemistry. And so when we redraw this molecule, it looks like this. Okay. And so from there, we can do the sharpless epoxidation. And so I'm just writing sharpless for short rather than rewrite all the reagents. So sharpless and the minus DET. And so remember, when we use minus DET and we draw the molecule the way that we've drawn it, the way that the book advocates, the advantage there is we can say, okay, well, we're using minus DET. So the epoxide is going to be up. The oxygen is coming from above. And then we can just modify the stereochemistry around the epoxide accordingly. So the allylic alcohol, of course, it's no longer allylic, but the alcohol is going to be on a dashed bond. So is a hydrogen over here. Oops, that's an oxygen. So is a hydrogen over here. And then the six-membered aromatic ring is also going to be, or not also, is going to be on a wedge. So there's that. And then a hydrogen will also be on a wedge over here. Okay, and so that's A. And again, that's the advantage to redrawing this with the horizontal double bond and the alcohol to the top right, is it standardizes this and makes accounting for the stereochemistry much easier, I think. I like this approach. So similarly, when we look at part B, we're now using the plus tartarate, the plus DET. And so we can say that the oxygen here is going to come from below. And so there's that. And then we just need to fill in the stereochemistry of the rest of this molecule. So C3. All right. So there's that. There's our hydrogen there. Hydrogen on a wedge here. And our allylic alcohol here. Okay, and so that's B. And again, I do like the approach that the book advocates. So always, when you're doing a sharpless epoxidation, if your molecule is not in this conformation where the double bond is horizontal and the allylic alcohol is to the top right, I would say redraw it. And then we just need to remember that the minus DET is going to add an oxygen from above, and the plus DET is going to add the oxygen from below. And then just account for our stereochemistries accordingly. And so that's the answer to Chapter 12, problem number 59.